Hi everyone, welcome to talk session. Let's continue with few more examples on designing of DFA. Here question is design DFA to accept all strings having number of a's are divisible by 5. First try to identify the condition and let's understand it. Here condition is given on number of a's and that should be divisible by 5. It means what? Suppose number of a's are 5. Then it's a valid string. If number of a's are 10, it's a valid string. Also if number of a's are 0, 0 is also divisible by 5. If number of a's are 0, that also becomes valid string. Hence based on this understanding of condition, write down the minimum length string. So which is the string which contains 0 number of a's? 0 number of a's means what? First if I write epsilon. Epsilon is an empty string. It does not contain any symbol. So it is not containing single a also. So epsilon contains 0 number of a's. Or sigma is given a comma b. If I write here single b, how many a's here? 0. It's a single b. So this also becomes valid string. If I write here double b, how many a's here? 0. If I write here triple b, 0 number of a's. Because here condition is given on number of a's and not on number of b's. So if any number of b's are coming, it becomes valid string. 5 number of a's. For example, if I write here 5 a's, there should be 5 a's. Apart from this, if any number of b's are coming, it also becomes valid string. Our concentration should be on number of a's and we should not focus on number of b's. Number of b's may come or may not come. That's not our question's condition. So once I understand the condition, let's start designing DFA for this question. First state is Q0. As epsilon is a part of minimum length string, so Q0 becomes final state. I have explained reason behind this in my previous examples. Now next valid string is 5a's. As number of a's are 5, divisible by 5. So this string should get accepted. It means what? After reading this string, automata should go to the final state. So first a, is it get accepted? No. So it should go to the non-final state. Second a, it should not get accepted. It should also go to the non-final state. Third a, 3a should get accepted. No, we want number of a should be divisible by 5. So it should also go to the non-final state. You might be thinking, why am I taking this number of non-final states? I could have taken the self loop. If I take the self loop at any state for a, it means what? 0 or many. Means single a also gets accepted, double a also gets accepted. So I am not taking this 0 or many. I want to concentrate or I want to restrict on number of a's. That's why on first, second, third a, I am taking new non-final state. Similarly, fourth a should not get accepted. Hence, I am taking new non-final state. Now, fifth a should get accepted because number of a's are 5, divisible by 5. So, fifth a transition from Q4 should go to final state. So, we can take new final state or I can connect the transition of this Q4 to Q0. As already we have the existing final state. And we should always remember that automata should contain minimum number of states. Hence we are connecting transition of this a from Q4 to Q0 unless and until it's not reading any other invalid string. This is not happening in our case. So we connected transition of a from Q4 to Q0. Hence we can remove this new state. It's not required. Now this example or this automata is on the number of a's divisible by 5. But we need to design DFA. It should be deterministic. Means what? There must be transition from each state for each symbol of sigma. Sigma contains a comma b. Here there is no transition for b. So we need to make this deterministic. How to make it? I will tell you the same trick. If suppose I want to make Q0 as a deterministic, write down Q0. For which symbol you are trying to find transition? I am trying to find transition for b. So write down that b also. Ask something to yourself, how to reach to Q0 from starting state. So suppose my starting state is Q0. So how to reach to Q0 from starting state? Q0 itself is starting state. There is no need to read anything. How to reach to final state from Q0? Q0 itself is a final state. There is no need to read anything. Then Q0 is looking for single b or double b is also accepted. Check. Single b contains 0 number of a's, accepted. Double b contains 0 number of a's, accepted. Also we have written all these strings in our MLS. So all these are valid strings. If suppose no b's are also coming, no b's means what? Nothing. Nothing means epsilon. Epsilon contains zero number of b's as well as zero number of a's. What I mean to say here, Q0 is looking transition for 1b or 2 or 3 or 100 b's. Can I say many number of b's? Yes. Our focus is on number of a's. Number of b's can be anything. Or Q0 is looking for zero number of b's. Epsilon means what? Zero number of b's. So Q0 is looking for zero or many b's. Zero or many, whenever you face similar kind of scenario, zero or many for any symbol, you can give the self loop. At which state? At state Q0. For which symbol? Symbol is B. So there will be self loop at state Q0 for symbol B. Now Q0 become deterministic because there is a transition for A as well as transition for B. Now similarly try to make Q1 as deterministic. How will you make Q1 deterministic? Same question, same process. Which state you want to become deterministic? Q1. So write down the Q1 here. For which symbol? Symbol is B. Ask similar kind of questions to yourself. How to reach to Q1 from starting state? Starting state is Q0. How to reach to Q1? By reading A. So write down that A here. How to reach to final state from Q1? So I want to reach from Q1 to final state Q0. This is what my requirement. So what you need to read? Q1 to Q2 you need to read the single A. Then Q2 to Q3 you need to read the one more A. Q3 to Q4 one more A. And then Q4 to Q0 one more A. It means what? To go from Q1 to final state you need to read the 4 A's. So write down that here. This is the one time you need to write it. Okay. So how to reach to Q1 from starting state? By reading A. How to reach to final state from Q1? By reading 4 A's. Now Q1 is looking for single B or double B. Double B can also possible. Check, are these valid strings? This A and this 4 A's are as it is. Here in the first string number of A's are 1 plus 4, 5. Yes, divisible by 5. In second string number of A here 1, here are 4. Again it's 5. It's divisible by 5. If suppose at Q1 3 B's are coming, or I can say 4 B's are coming, or if no B's are coming, check are all these are valid string or not. If no B are coming means how many number of A's? Again it's 5 only. If 4 B's are coming but number of A's are same, here we are increasing number of B's and number of A's are as it is. So all are valid string. What I mean to show here, Q1 is trying to read 0 number of B's as epsilon contains 0 number of B's, or Q1 is trying to find transition for 1, 2, 3 many B's. So 0 or many scenario for which symbol? B. So as we know, whenever there is a scenario of 0 or many in TOC, you need to give the self loop. At which state? State is Q1. So at Q1 there will be self loop. For which symbol? Symbol B. Now Q1 is deterministic. Similarly, you can find out transition from Q2 for symbol B. What you need to do? You need to write down the same thing. You need to write down transition. For which symbol you are going to find transition? So symbol is B. At which state? State is Q2. So write down the same thing here. State is Q2. Which symbol? Symbol is B. Ask yourself how to reach out to Q2 from starting state. This is my starting state. How to reach to Q2? By reading the first, second A. So 2 A's. How to reach to final state from the Q2? By reading first, second and third A. So write down these 3 A's as it is. It means what? Q2 is trying to find transition for B. Is this valid string? Yes, because number of A's are 5. Is Q2 looking for 1B or double B is also allowed? Double B also allowed. Triple B also allowed. Because number of A's will be 5 only. Starting to Q2, 2 A's. Q2 to final, 3 A's. Here number of A's are not going to change. So again the similar kind of scenario. Q2 is looking for epsilon also, means 0 number of B's also, or many number of B's also. Again there is a scenario of 0 or many. At which state? State is Q2. For which symbol? Symbol is B. Similarly, you can find out deterministic transition at state Q3 and Q4. I would like to tell here reason conceptually behind this. You can follow the same practice here. You can write here Q3 and you can ask how to reach starting to Q3, Q3 to final. You can write it. Or at the end you can say like this also. Suppose there are 5 A's. My string is valid. Before this A, if any number of b's coming, maybe 0 number of b's or multiple number of b's, my string is not going to change because number of a's are same. In between these two a's, if 0 number of b's are coming or multiple number of b's are coming, it's not going to change. In between these two a's, if 0 number of b's or many number of b's are coming, number of a's are as it is. I'm just trying to add here many b's or 0 b's. Similar kind of scenario between these two a's, many b's or 0 number of b's. Similarly here, 0 or many b's. My number of a's are not going to change here, it's 5 only. So my string will always be valid as I am going to add or remove some number of b's. Whenever I say 0 or many b's, it means what? There is a self loop. So in between any two a's, there will be always self loop. And that's what we have added. At Q0 we have self loop for B, at Q1 we have self loop for B, same at Q2, and similarly will be at Q3 also, Q3 and Q4. And hence we have transition for each symbol from each state, and this becomes our deterministic finite automata. You can follow this trick in further questions also. You can practice similar kind of scenario where number of ones are divisible by 5 at sigma is 0, 1. In next few sessions we will be learning how to design DFA which is going to accept all binary numbers divisible by 2, 3, 5 or ternary numbers divisible by 2, 3, 5 or decimal number divisible by 2 or any other number. I'll be telling one short trick. It will take only 1 minute to write down this DFA. Thank you for watching.